everyone. So today we're going to finish up our 8.6 notes. So we started this in class the last time I saw you, and today we are going to be working on finishing it. So before you start, you should either print out the 8.6 solving rational equations page 2, or the sub should have an 8.6 solving irrational equations page 2. So there are 4 more problems we're going to look at practicing our solving. Okay, so here is the first one. And these steps that we're using are actually on the first page of our 8.6 notes. So the same few steps, we're just going to do a couple more problems. So the first step says to factor the denominator if needed. This is a problem where we have an x plus 1, an x plus 4, and x plus 4. So there's no need to factor. So we're going to jump to step 2, which is to find the least common multiple of the denominators. So if you look in the denominators, the first thing I see is we have an x plus 1, and we also have an x plus 4. Okay, the LCM says we must account for everything once, so I'm going to say, okay, my LCM is x plus 1 and x plus 4. Okay, so there is find the LCM of the denominators. Okay, we're then going to use that LCM to go ahead and identify our restrictions. So if we have x plus 1 in the denominator, that tells us that x cannot be negative 1. If we have a plus 4 in the denominator, then that tells us that x cannot be negative 4. Okay, so there are my first 3 steps. For solving, we said we're then going to multiply everything by the LCM. So I'm going to take the LCM, which is x plus 1 times x plus 4, and I'm going to multiply the entire equation. So I'm going to multiply x over x plus 1, and then 3 over x plus 4, and then x plus 3 over x plus 4. So I'm going to multiply all 3 pieces by the LCM. And because this gets lengthy to write, let's go ahead and talk about what's going to happen. So the first piece, if I multiply the LCM, the x plus 1s are going to cancel, and I'm left with an x times x plus 4. And the second time, I multiply by the LCM. Okay, I'll do that one in green. The x plus 4 is going to cancel with the x plus 4, but I'm still left with a 3 and an x plus 1. Okay, the last time I do this, the x plus 4 is going to cancel with the x plus 4, and I will be left with my equals. I'll have an x plus 1, and then the numerator, which is the x plus 3. Okay, notice when we cancel what we can, this says we should have no more fractions. If you still have fractions left in your problem, that means that something went wrong. Okay, so now we're going to get to step 6, which is to multiply by what's left, and then we'll kind of go from there. So when we multiply by what's left, I've got an x times x, and x times 4. So I have x squared plus 4x. I have a 3 times x and a 3 times 1. So I have plus 3x plus 3 equals. On the other side, we're actually going to have to FOIL. So I've got x times x, which is x to the second, x times 3, which is 3x, 1 times x, which is just positive x, and then lastly 1 times 3, which is a plus 3. Okay, so there's my multiply by what's left, and we're also going to go ahead and simplify. So that means combine like terms. So on the left, I have an x squared, 4x plus 3x gives me 7x, and then plus 3. On the other side, I have an x squared. 3x plus x gives me 4x, and again, I have a plus 3. So a lot of times when we have x squareds left in our problem, we're going to have to factor, possibly solve using square roots. So for this, I'm going to go ahead and try to solve. And the way I'm going to do that is I'm going to move everything on the right over here on the left and see what happens. So I'm going to subtract x squared from both sides. And both of those x squares are going to cancel. I'm then going to subtract 4x from both sides. And 7x minus 4x becomes 3x. So those are gone. I'm going to then subtract 3 from both sides. And again, it just so happens that on both sides they cancel. So I have 3x equals, if everything cancels, then we have equals 0. So my final step here is divide by 3, and 0 divided by 3 tells me that x is equal to 0. Now before we move on, I want to remind you we had some restrictions. So the first thing, one of the first things we said up here was that x could not equal -1 and x could not equal -4. So as long as my answer isn't part of my restrictions, I am done. But if I want to go ahead and add, okay, where x cannot equal -1, x cannot equal -4, a lot of times that will be included in our answer. And we can check it if we want to by plugging in. But for now, I'm just going to go ahead and leave it alone. But plugging x back in for all the x values, making sure it works out is always a good idea if you're not sure if your answer will be correct or not. All right, so there's the first one. Here's the second one. Again, first step is to factor the denominator, but in this case, we do not have to factor the denominator. So I'm then going to look to identify the LCM. Keyword here is the LCM of the denominators. Well, if you look at this problem, there's only one thing in the denominator, and that is x. So LCM is x. I'm then going to identify my restrictions. If x is ever by itself, then that tells me that x cannot equal 0. So I have my LCM and I have my restrictions. So from there, we're going to multiply everything by the LCM. Okay, so what that looks like is we have an x, we have a 6 over x, we have it equals -5. I'm then going to come take the first piece times x, second piece times x, and the third piece times x. You'll notice that this denominator here is now going to cancel, which we said is correct. We should have no more fractions. Okay, so we cancel what we could. Okay, we're now going to multiply by what's left and then see how we can simplify. So we have x times x, which is x to the second, plus 6, and -5 times x is -5x. Now here's where we've got to talk a little bit about what's happened here, because we now have an x squared left in my problem. If we ever have an x squared left in our problem, when we have an x term, we usually have to solve either by factoring or by using the quadratic formula. No matter which of these two methods that you use, you're going to have to get the problem set equal to 0. So that's what we're going to do now. And when we get ready to solve it, we're going to solve by factoring. Okay, for this one, again, I'm going to factor because we still have an x squared. I mean, you could use the quadratic formula. Either way, we've got to get equal to 0. So I'm going to add 5x to both sides. So I have an x squared plus 5x plus 6 is now equal to 0. When I go to factor, I'm looking at factors of 6 that sum to give me 5. So I get 2 times 3. Because 2 times 3 multiplies to give you 6, but they add to give you 5. Since 5 is a positive 5, both of these are going to be positive. So we get x plus 2 times x plus 3 equals 0. And remember from chapter 5, the x values then are always the opposite of the factors. So my first answer is negative 2. My second answer is negative 3. We said earlier that x could not be 0. So as long as these answers aren't 0, we can go ahead and circle them and move on to the next one. Okay, if you wanted to check them, we could plug in negative 2 for x. So if you wanted to check, we could say, okay, negative 2 plus 6 over negative 2. And see, does that give us negative 5? Well, 6 divided by negative 2 is negative 3. And negative 2 plus negative 3 does equal negative 5, so that works. Okay, on the other side, if we took negative 3 plus 6 divided by negative 2, or sorry, by negative 3, and tried to see if that equaled negative 5, we would get negative 3 plus negative 2, which also gives us negative 5. Okay, so there's an example where I checked it for you. All right, so this next one is a little bit different. Okay, this time if you notice there's a bunch of letters and they're asking us to solve for f. Well, f is here. And before we do this, I want to remind you, if you look at your page 1 notes, we said anytime we have a fraction equal to a fraction, you can skip all the complicated process, and we said that you can cross multiply. Okay, so the way that I'm going to solve this is I'm going to cross multiply. So I'm going to start by taking f times 1 and setting that equal to m times a. Okay, f times 1 is just f, m times a is just ma, and we would be done. So a real quick example, just wanted to show you one where they have all variables and not a lot of numbers. So you do it the same way, you just have variables left in your answer. Okay, so the last one. Okay, the last one is one where we actually have to go through and we have to factor. So first step, factor the denominator if needed. So I'm going to rewrite, I have 1 over b plus 1 plus 1 over b minus 1 is equal to 2 over, if I factor b squared minus 1, we have difference of 2 squares, so I have b plus 1 times b minus 1. Okay, step 2 says we're then going to find the least common multiple of the denominators. So I'm going to come and say, okay, I'm looking for my LCM. Well, I have a b plus 1 and I have a b minus 1. Okay, that tells me that b cannot be negative 1, nor can it be 1. So I've got LCM, factored, restrictions. We're now going to take this and we're going to multiply each piece by the LCM. So I'm going to take b plus 1 times b minus 1 times 1 over b plus 1 plus 1 over b minus 1 equals 2 over b plus 1 times b minus 1. Okay, so if we look, the first time we do this, the first term, the b plus 1s will cancel. And I'm left with a 1. Well, I guess I should. Times the b minus 1. Okay, so I'll show again the b plus, okay, the b plus 1s will cancel in that first piece. A second piece, the b minus 1s will cancel. So what I would be left with is a plus 1 times b plus 1. And the last piece, the b plus 1s and b minus 1s would cancel. So all I would be left with is the equals 2. So now we can multiply by what's left, and we can simplify. 1 times b minus 1 is b minus 1. 1 times b plus 1 is b plus 1 equals 2. We have a minus 1 plus 1 on the same side. We have a b plus b, and b plus b is 2b. So 2b is equal to 2. So I'm going to divide both sides by 2, and 2 divided by 2 equals 1. Okay, so then we went through and we solved. So a lot of times y'all will get going, and you will then circle this, and you'll move on to the next problem. However, we said at the beginning of the problem, in my restrictions, that b could not equal 1, nor could it equal negative 1. But right here we have b equal to 1. Okay, so here's what we're going to put in this last blank at the bottom. If a solution is a restriction, okay, so if we have a solution, okay, if a solution is also a restriction, then we say that it is an extraneous solution. And if you have an extraneous solution, then you do not circle it. So when we solved, we got b equal to 1, but we said that b cannot equal 1, nor can it equal negative 1. So my final answer is going to be that there is no solution because b equals 1 is an extraneous solution. Okay, no solution.